QCon AI, the Practical ML conference for software engineers, returns to San Francisco April 15th through 17th. Discover emerging AI trends, essential tools, and how to apply AI in your software projects. Save $80 using the code InfoQ19. Find out more at qcon.ai.
According to some research, the global bra market is expected to be worth $30.4 billion by the end of 2023. $19 billion of that is in the US alone. With half the population wearing bras, this is starkly offset by an industry that's seen little innovation. An industry characterized by awkward fitting experiences, often a poorly fitted product that, while worn by women, was designed by a man 100 years ago, and a lack of personalization. It's often cited that 70% of women wear bras that don't fit them properly. Hello, my name is Wes Rice, and I chair the English-speaking QCon software conferences. QCon is a software conference that targets senior developers and architects. Today's guest is the Director of Data Science for ThirdLove, a company poised to disrupt this market and is leveraging machine learning to differentiate their product. Megan Cartwright, as I mentioned, heads data science at ThirdLove. On today's podcast, Megan talks a bit about the ThirdLove story, understanding how to get to product and market fit for the startup. We'll discuss their approach to developing an MVP, where they are today, how they got here, where they're going, and we're going to focus on their machine learning story. We're going to talk a bit about how they got to clean data, how they got to feature extraction. We're going to talk about A/B testing, deploying, validation. We're going to talk about offline versus online training and what you really need to get to an MVP for a product today. And then finally, we're going to talk about future plans. As always, I'm simply floored, honored that you choose to bring us along your commutes, runs, and downtime. So thank you for joining us on the podcast. Megan, welcome to the InfoQ Podcast.
Well, thank you for having me. I'm so excited.
Yeah, it's awesome. I really enjoyed your talk at QCon San Francisco this past November, so I'm looking forward to asking you some questions.
All right, let's do it.
So tell us first about this story. I described a bit about kind of the market for bras, but why is this such an industry poised for disruption?
I'll just start from the beginning, which I think is a common story for women, especially of like my age, in your mid-30s, where our founder, one of our founders, Heidi, needed a bra for a party she last minute had to go to. And so she ran over to Victoria's Secret, got an ill-fitting bra that was really expensive, and was just so embarrassed that she had to even go into Victoria's Secret that she hid the bag in her backpack as she ran back to the Google campus. And she's like, enough is enough. This bra didn't even fit her well. It was uncomfortable. And she was like, no, women deserve a better option. Right now we're kind of stuck with two options. One are these legacy carriers that really are like Victoria's Secret, where they have a very limited number of bras in terms of their sizing, which they actually are proud about, as they claim to be. They only want to fit a certain size woman. Or these other companies who are doing kind of the fast fashion type stuff like Zara and H&M. And so you never know what's going to be in stock, what it's going to look like. But a woman wears a bra every day for years and years and years, decades. And so our mission at ThirdLove is to make every woman feel confident in their everyday lives and wear a bra that fits them well, that is super comfortable and also beautiful. So that's a little bit about why the company was started.
Obviously, you all are using technology to help improve this experience for women. Can you talk a bit about this journey, where you started and kind of what the product looked like in the beginning?
So they started the company, and we actually started, knowing that we really wanted to be inclusive for all women. And they thought, well, how we currently do sizing is you go into a store and some stranger, touches you and gives you a size, and then you wear that size because they're the expert. And we wanted to help women not have to go through that process. And there's a lot of women where you can't even do that kind of process anymore. There's not these stores, Nordstrom's, these big brand stores. They're not in every market. So we thought, we'll do a mobile app. And that's how we started, was actually doing a mobile app where you could take pictures. It would be very modern. We'd give you the right sizing based on the pictures. And what we found was that it works, but it's also not as easy as we wanted it to be. And so we thought, how can we make this even easier? And not every woman has an iPhone or something like this. So it's not as inclusive as we wanted it to be. So we're like, nope, we're going to ditch all that effort. We're going to move to Shopify and create a website. And on that website, we are going to have a quiz that people can go through, and using a series of questions will give you a recommendation of your size. And we felt so good about it that we actually decided to start a program called Try Before You Buy. And so you could try the bra on. If it didn't fit, we weren't going to charge you and you could send it back. And once we did that, it just took off. It went crazy. And we still have the Try Before You Buy program, but we're also trying to spin up other programs, which you might think may be more beneficial because you only get one size in that program. So we just launched a new initiative called a backup size, which we're testing out, where you can actually get 1, 2 sizes, or maybe even 3 sizes in future. And that was actually driven in part due to our machine learning that we added into the product, which we'll talk about later. But what we found was that women could actually fit multiple sizes potentially, because women's bodies actually change over the course of a month. And so sometimes they get larger, sometimes they get smaller. And so it's a little bit tough to distinguish what size you currently are on that day and what you might be going forward. And there's also another component of bra fitting. While we know you were going to fit this size, there's something we like to call that's expression of fit, which means that some women just don't want to wear that size. They don't feel comfortable with the band being as tight as it needs to be to support all of the breast tissue, basically. And so they want a band that's a little bit looser. And you know what? Why not give them that? So I would say it's a smaller percentage of our customers, but there's still a percentage there. And we want to make sure that everybody is happy in their fit.
Yeah, you said something in your talk that women are very associated to a specific size or attached to a size, that's my size. So if you're making a recommendation using machine learning, that they may not accept it. So this backup actually gave them ability to try both.
Exactly. And it's very confusing if you've been wearing one size for 10 years and then now you're all of a sudden a different size. And some women, we recommend sizes and styles. And in some styles, you may feel more comfortable with a different size. And so they should be able to choose that.
So I had 3 different people go through and take the survey to kind of give me some feedback on what they thought. One of the first things that they said was there's no actual measurement. It's just questions. So how do you recommend a bra size without actually doing a measurement, with just asking questions?
We started the quiz. It was developed by Heidi, our CEO, and Rael, our Chief Creative Officer. Rael's been making bras for 20 years and fitting women in bras for 20 years. And so she knew the questions, she knew the pain points just from this experience. And basically they coded up her knowledge into this quiz. And that was where the start of these questions came from. And from there, they knew that they wanted to use machine learning on these questions, but they knew they also needed to collect data. And I think this is a special story about ThirdLove, is that data started at the beginning. They started collecting this data. It was collected in our back end, and they saved it for 6 months. And then they hired a head of data engineering who put it into a data warehouse. And then they hired a data scientist, which was me. And they said, hey, we really want to revolutionize bra fitting using machine learning. And we've collected all this data and it lives in here. We have something like 10 million data points or 10 million people who've done this quiz. Can you use this for something? And I said, yes, I can. So that's how it all started.
Let's back up for a second. So let's walk through what is currently there. So you mentioned that there's a survey. So you've got a site that's hosted on Shopify, and then you've got a survey that people take, and that you've had 10 million people take this that feed to a backend. Is that right?
Yes.
Okay. So walk through. You said Shopify, it's a React front end. Walk through what's there right now.
So right now, when I started, and it hasn't changed too dramatically since then, is that we're on Shopify. But the quiz actually is a JavaScript React web app that we built. It's hosted on Heroku currently, although we're moving off of that. And then we are actually using the parse server basically to go back and forth between Shopify and the client.
For your backend, yep.
Yeah. So when I came in, I looked at all of this and I was like, great, let's just add an endpoint somewhere. And if we had an endpoint, we could put in a machine learning API. So that's what we did. We just made a very simple thing.
So you use Shopify, you've built a front end, you use the parse back end, you're running on Heroku. It seems like a very intentional, lean kind of approach, at least for the software architecture.
It's a very lean approach. We wanted to develop the product and be able to test different like UI and UXs, different context of the questions, different wording of the questions. The questions, when they first came out, might have been a little bit too technical for some people. When I started here, I didn't know anything about different styles or the sizing structure of bras. You know, I was a physicist. I've worn bras, but I didn't know what a plunge was from a t-shirt demi. And so making those questions a little bit more personable was something that the product and eng team wanted to do. And so they put most of their effort in that side of the house. So having a very simple backend really allowed us to work and iterate on that part.
So when you came into the company, the product was being sold, right?
Oh, yes. We were taken off.
So then presumably it was more like a rules engine when you came in where, you know, if this, then that?
Yes, it was exactly a rules engine. It was actually on the client side in the JavaScript web application. There was a simple, well, it wasn't simple, but there was basically an if-else statement. I call it like the rules algorithm. It's like the first thing that we started with. And that's what Heidi and Rael had coded up.
Okay, so you've got this product that's being sold. You're on Heroku. You've got Shopify. You've got this parse front end, and you've got rules that are kind of like deciding on what product to recommend, and they hire a data scientist. What did that look like?
At first, I was really excited because I had been told there was all this data. And then I actually dug into the data warehouse. You know, we had one data engineer at the time, and he had worked very hard to get all the data in the data warehouse, but it didn't mean it was something I could actually use. And then, of course, you find out all the fun things like we didn't actually track every session a user did of FitFinder. So if you did FitFinder once, and then you wanted to come back and do it again, which people often do, we weren't saving all the information. So the very first thing I did was say, no, we have to save all the information. And that blew up our data warehouse a bit more, which was great for me as a data scientist. And then I had to go, and luckily the data was pretty structured because the questions are pretty structured. And that means that when we ask a question like, what is your current bra size? You have to answer something. You can't input some random size. Whereas if it was unstructured, it'd be a little bit more challenging. We do have some unstructured questions such as brand size, like what brand you're currently using. Are you using Victoria's Secret or, I don't know, some other brand? And you'd be surprised that like they'll write in Victoria's Secret, even though it's an option. So there was some work there to clean up the data. But I decided to be very lean in my data science approach. So the first thing was, can I actually build an algorithm using the data we have? And if I can, and it looks like it could actually perform similar or better to the current rules-based algorithm, I was going to hire an engineer to work with me to build out the API service.
What did that look like? How did you identify your first features? How did you clean things up to create those features so that you could get to this algorithm? What did that process look like?
So if someone does a FitFinder session, I took all of their questions. And then if they made an order, which is only a subset of everyone who does FitFinder, then I put that into its own little table in our database. And then I analyzed that data. I basically was only concerned about an MVP. So I decided to have a bunch of assumptions. Like, since I knew we didn't have historical data on the number of times someone took FitFinder, you know, pre or post a purchase, I just decided to only look at people who did FitFinder once, who had full data, no data loss. I didn't want to worry about cleaning up the features too much because I just wanted to know what was there. I did have to make a call on like grouping the features together, thinking about how you would encode the features, because you don't want to blow up your dimensionality space within your algorithm. So you don't want to have something like 200 columns within your algorithm. It may not perform really well. You'd have to have a lot of observations, a lot of rows, basically. So these were the things that I was most concerned about in the beginning. I wasn't really concerned about knitting features together because I decided to take a random forest algorithm approach, which out of the box, random forest is probably one of the easiest, most efficient ways to create a recommendation. And surprisingly, what we found is we've been working on really advanced algorithms since then. And my simple random forest with like features that aren't really like knitted together well works pretty dang well.
So how many data points did you actually measure and track against for that first algorithm?
This is like slightly embarrassing, but I only used about 100K. So I think that's a learning. I mean, I actually came from physics where my PhD was literally off of like 50 data points. So I knew I could create something with not like a huge amount of data, as long as you had the right structure of your training data.
But let's go back. You had 9 million surveys, right?
Well, we actually had more than that. But then with all of my little assumptions, which actually was a lot of assumptions, which now we're peeling back, to create better algorithms. It was just a really small sample of really clean data. And it was actually only a subset of all the sizes we carry too. So I wasn't concerned with the edge cases, with the cold start problem, which is as we add more size. We added 24 new sizes the same week I launched the alg in product.
Nice.
And I was like, this is not something I can predict.
It was an MVP, right?
MVP. So we actually still have a rules-based algorithm for our new sizes that we onboard. And I now have a data scientist who's looking at that and trying to do some, Bayesian structural analysis or something around how can we really rip out the rules for these new sizes.
I want to really focus, at least for the moment, on that first kind of getting a machine learning product into a production environment, because a lot of people want to be able to leverage machine learning, even very, very large advanced places. It's just that first story about how to get there. What do they need to do? So I'm really curious about that particular part. What did you actually use to be able to do this? I'm assuming Python, scikit-learn, offline.
I knew it had to be something like Python and scikit-learn. That was like what I was starting with. I'm very familiar with R and Python, a little familiar with like Keras and things like this. But I knew for this project, we just needed to get up and moving. And probably the easiest way to do it is using Python, which our current team already uses. So I was like, what do we already use? And the team is familiar with, and how can we do it in a way that fits nicely within our infrastructure? And also, how do you even do it? So let's maybe start with that point. The team we had, no one had built an API because we didn't really have a back-end team. We were cheating and using parse. And so I was like, all right. So I just went around and started asking my friends. We're taking them out to coffee. I think I went on like 10 or 12 coffee dates with my friends, with my husband's friends, because my husband actually does machine learning as well. And I'm like, what's the best approach to do for this problem? Like something easy, simple, we can get moving quickly. Because, I'd been at the company for maybe like 3-4 months, got the data cleaned up, validated I could build a model. Then how do you do it? What everybody was saying, I did have a solution in my mind, which was like a RESTful Python API using Docker or something like this. But I still didn't know how to build it because I'd never built one before. A friend of ours who I was having coffee with was like, well, if you want, I'll contract out for you. I'll build it for you. I'll make it so easy that you can deploy it yourself. I was like, done. So we signed a contract like literally a week later. He had done this many times before, and he was between startups at the moment and was just basically doing contract work for like other companies, big companies actually. And then I was just really honored that like he would work with us on building this out, just as a kind of a favor, really, just to see if it would work.
So offline, you use Python, scikit-learn to build a model, and then you uploaded the model in front of a Python API?
So it was so cheap and easy. I'm telling you, we built everything within our first MVP was one Docker image. It was all the same Python version, all the same scikit libraries. Everything we needed for the alg had to be the same thing as the RESTful API. And then we just exported it into Dynamo. We used Dynamo as the backend to call the classifier up. And that was it.
I should have asked this earlier. How long has ThirdLove been operating, and how long is this window we're talking about to get this first algorithm out?
So we launched the Finder quiz, like the online quiz with the rules based. I believe it was like mid 2016. They hired me at the end of 2017, and they had done a lot of tweaking on the front end of the quiz, changing the questions, blah, 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 for about 6 months. So I had about 8 months of data when I started. And then after I figured out how to get the data in a useful place, that took a month maybe. And then, could we really do this? Is there actually appetite within the company to build this machine learning algorithm? Because even though we wanted to, you still have to, make sure everybody agrees with you and believes this is something we can do and valuable. And that took another month or so to build that roadmap and strategy out. Also, how would I even do it? That's me having coffees with people. And then we started actual work in March. It only took a month, really, because I had all the algorithm kind of ready to go. When my friend came on and contracted for us, I think he was in the office for a week. He built out the kind of the API service, and I had it on my laptop. And then we deployed it, which then was used by our backend.
Where was the container deployed? Heroku or?
The container was deployed on Heroku, which is actually where our parse, it all lives in the same Heroku environment.
Yeah, very cool. Okay, so that's just the start of the story, right? Once you got that first model out there,
yes,
orders are still coming in. You still need to continue refining this thing. What did that look like?
Then we're talking about validation, and we decided to do something called shadow launch, which allow every request that was coming through to be evaluated and fit by the alg itself. And then through a fire hose, dump that data into our Redshift cluster, or S3 to Redshift. And we did that for maybe a week and validated that everything was working right. Inevitably, there was something that was funny or an edge case we hadn't thought about.
So this is side by side with the rules engine. The rules engine still running, still serving requests, and you're just shadowing the traffic off to it to kind of do a A/B test between the two to sort of say, how are these running?
Yeah, it was a fake A/B test, essentially, just to make sure the infrastructure was working and that we weren't going to tank the business by turning on machine learning. And then when we validated it through our shadow traffic, we decided to run an A/B test on, I think it was 10% of traffic. And, we're still a startup. So we still are using a company called VWO for our A/B testing solution. And of course, me as a data scientist, I actually want to track all the touch points of a customer within that test. And they'd never done that before. So that was a whole new infrastructure we had to build out with our clickstream data. Luckily, I'd done this before, so I knew what I was getting myself into. So we turned on a VWO test where VWO basically partitions the traffic for us. And if it said, machine learning true, it will go to the API and pull up the classifier and then send the results back. So that's how we started. And now we're actually default. That algorithm that we first launched is now our default algorithm.
What about continuing to train this? How do you keep retraining this algorithm, this model? What does that look like?
So once we realized, we ran the A/B test on 10%, upped it to 50%. Everything still looked pretty good. So we upped it to 75% or something. We got results back saying machine learning is a winner. Let's make that default. And I knew at that point I needed to build a proper team, which, at a startup, that means one person. Our engineering team was actually in Cordoba, Argentina. And we did have a bunch of engineers down there who were super fascinated with what we were doing. And one of them, he actually does specialize in back-end engineering. And so he reached out to me and said, hey, I'm really interested in this. This is what I've done in the past, blah, blah, blah. And so we started working together. I said, well, I need to deploy a new alg. Let's just deploy alg v2. Alg v2 was actually predicting more sizes than we initially predicted. Everything was really the same, but just predicting more sizes. But of course, you want to test that out. And so he was like, all right. So he took everything we had done, kind of chatted with our contractor, looked at all of our notes, came up to San Francisco, and we worked side by side for a week. And basically, he was like, okay, we can't keep doing things this way. It's too MVP. We need to think about continuous deployment. We need to think about how we're going to automatically retrain this stuff and how we wanted to, redeploy the backend, because we were tied to parse which meant we're on the same Heroku cluster. So you have to deploy the whole thing and run regression tests on everything. And so it's actually a little bit clunky if you want to iterate quickly. So I said, okay, first things first, let's go to continuous integration. And we're using Circle CI. So we basically, in that next V2, we just put it all into Circle CI. It's all automated now. The only non-automated part is when we actually make the classifier and the transform function, we do have to, send that as a Git pull request, basically.
So when you say it's automated, what does that mean? Is it actually go through and canary it out and just do that kind of partial load? How does it evaluate whether this is successful versus more successful than a previous model? How does that all process work?
Yeah, I think we're just finishing up this week on that process. We decided to re-architecture the backend, of course. I'm just like blowing up the backend at my company here. But, we actually have a team of 3 now in Argentina, I believe. And so we had to hire up a bit and then train them, and then we could start working again, basically. I mean, mostly it was just how do you redeploy the API and the infrastructure, that service within Circle CI, not the whole end-to-end, because we're not quite there yet. Again, it's the MVP kind of thing, steps. And then we're moving towards how do we automatically retrain the model every month, because our newer feedback data is better than our older feedback data. We're still a young company and our product is amazing, but we're still in that fun stage of onboarding. Our demand is too high for the amount of product we're actually getting from our manufacturing companies. So we're onboarding new manufacturing companies, and sometimes they work out and sometimes they don't. And so we don't give any product to anybody that we think is going to be bad. So it can be a bit of a challenge. We're in that kind of fun stage.
Are you using machine learning specifically for making this recommendation, or are you using in other parts of the business yet?
We are using machine learning across the business. So in addition to building out this was kind of our V1 or the first machine learning algo we did in product. We have a couple other endpoints that we're working on right now around returns and exchanges. Our return exchange process, we completely want to redo. So we know that if you've bought something and you didn't like it, then we should make sure that we get something you like, and that's on us. So we're working on that. Machine learning and data science runs, I feel like it's almost across every business function at this point. In addition to being in product, we're also big time into marketing, big time into all of our acquisition and retention levers, big time into like financial planning, big time into inventory forecasting. We're really spinning up across the business right now. And I feel like our job at data science, which includes analytics and algorithms, is to really inform and give better information to our business partners. So then they can like join that with their thoughts and then make a better decision.
Human in the AI loop, right? So are all of these kind of that same Python with scikit-learn wrapped up into a container, wrapped up into an API, and then done offline, then deployed to a production? Is that the process?
Some of them are. Not everything is. I've hired a team of 4 now in the last 6 months, I guess. And so just to get us up and running, I'm allowed the team to use whatever they want to use. I don't care if it's R or Python or whatever you're comfortable with, just get it done. And then now we're kind of having to backtrack a little bit and be like, okay, let's make sure that if this is all like working well, we're all using best Git practices. We do like use Git, and we do deploy we built something called a media mixed model, which allows us to understand all of the different online and offline marketing channels we have. And it allows us to understand like what spend we should do. Like if we want to spend X amount of dollars next month, how should we spend it to get this many orders? So it's allowed our team to really do that. But that's like hosted now on Heroku as well. So then people can access that web app that we built. We're actually changing our entire architecture into AWS.
This is the part where I ask, what's the future plans?
Future plans are, we just hired a VP of engineering. So that's very exciting for me. And I will report into him. And I'm just really excited because he loves machine learning, he loves serverless architectures, he loves really thinking about how to do this in a scalable, efficient way. So we will be probably moving off parse at some point, but very slowly. So the first part is to really take all of Bitfinder out of parse, put it behind an API, and host that on AWS. So any part of the company that wants to access anything related to that can do it that way. And then we'll start ripping other things out of Farce.
And you said serverless. Are you planning to leverage serverless with that solution?
Well, we're evaluating it right now. I'm all about what's efficient. Is it easy to use? Is it reliable? I think that's kind of a question we're leaning on. We're still a lean team and we want to move quickly. And if that makes sense, I will definitely use it. So I would say we probably will.
So that's really awesome. I really like the kind of pragmatic view of early startup trying to get machine learning into production, kind of the steps you went through, the thought processes that you went through. So I really appreciate you sharing that with us. So what's been your big takeaway now? If you were to kind of reflect back and kind of recommend to people how to move forward and the lessons that you maybe learned along the way, what might that look like?
My takeaway from this is I started here to build an algorithm in product, ideally real time, because I'd not done it before from scratch. I'd always used other people's algorithms, and I'd seen some really weird solutions about how to service this to the front end, and I didn't understand it. So I was actually a little terrified of taking this job because I didn't know what I was doing, but I just knew I wanted to do it. And I was really pleased with the fact that, if you reach out into your network, if you just ask questions, you can actually get a lot accomplished really quickly. You don't have to be fancy. You don't have to use deep learning, which of course was asked, why aren't you using deep learning to solve this problem? I'm like, well, it's not time series for one. And that's my moral to the story.
But you can take a lean approach to an MVP with machine learning, and this is how.
You can. So we're not Facebook. We don't have whole teams that are just focused on feature engineering or, deployment. We're kind of all in one shop here.
Megan, thanks for joining us on the podcast.
Yeah, thanks for having me.